Hello, and welcome to the Google Earth Area Project for the Ritti Grant 2009. We're going to start with Google Earth already open, and we are going to input a destination we want to find the area to in the search box located up here. I'm going to input Aldrich Junior High. It's the building I work at. Once you enter a location into the search box, the computer will automatically find your location in Google Earth. Now I can see that it says here Aldrich Junior High, so I might have to zoom in a little bit further. To get the layout of the building. So this is Aldrich Junior High. I can see that it's a composite area, meaning the area of the building is made up of a sum of a bunch of areas. So I have one large rectangle with two holes, so I'll have to account for those. I have a new wing that is a rectangle also. And then I have a gym that juts out into the parking lot. Not all of it, but some of it, and we'll have to factor in that also. So it's good to get a plan down on paper. So I'll open up a text pad here, and I'll label this area of Aldrich Junior High. I'm going to start with the area of my large rectangle. So I'll just put that, large rectangle. Now I'll have to add the area of the new wing. Which is also a rectangle. And then I'll also have to add in the small part of the gym that juts out. Now I said I had to keep track of these small rectangles here. I will do that now by subtracting them out at the end. So 2 times these small rectangles. On this next line, I'm going to put the formulas and the dimensions I need to find this composite area. So the large rectangle is going to be simple. That's length times width. The area of the new wing is also length times width. The area of this small part of this gym is also length times width. And then my 2 holes here is going to be 2 times the length times width of those rectangles. In order to find these dimensions, I'm going to use the ruler function. So by clicking on the ruler here, you get a box where you can choose from a variety of measurements, units. I'm going to choose meters for this case right here. I'm going to start with the large rectangle, and I'm going to find the length. The length here is 70.42 meters. Go back here. Enter that. I'm going to find the width of the large rectangle to be 50.18 meters. I'm going to go to the new wing here. So I'm going to bring this over here like this. I'm going to find the, let's find the length first. The length of the new wing is 22.22. And the width to be 21.23. I'm now going to account for that small portion of the gym. The length being 24.72, let's record that. And the width being part of the gym up to where I measured the rectangle, 11.74. I now have to account for my small rectangles here. Finding the length of 9.24 meters, so minus 2 times 9.24. And the width of 9.99. Okay, on this next line right here, I can use a calculator to find the dimensions of each composite. So if I start here, I got 70.42 times 50.18, and that is 3,533. .68. I'm going to add that to 22.22 times 21.23, 471.73. Get the gym, 24.72 times 11.74, 290.21. Remembering to subtract out my small rectangles, I'm going to 2 times 9.24 times 9.99. 184.62. Okay, now that I have the sub dimensions, I can now find the area of the whole building. Starting with 3,533.68, adding 471.73, adding 290.21, and then subtracting 184.62, I get 4,111, and that is going to be in square meters. So there's a lot of different shapes and you can use here. Looking at Aldrich's field, I can see that it is in the shape of a parallelogram. I've found that pools make good circles. So if you want to find the area of a pool from space, you can do that using the ruler function. So I hope you enjoyed the tutorial. Have